Hi. When you get more and more advanced into robotics, those simple servo-driven builds gets really limiting. That's when you start looking at more advanced stepper-driven robots, so basically professional ones in more home version. At least that was my story. After making my first servo-driven robot and playing some with it, I made this. Dragon R1, a project that I originally planned for max 3 months, including 2 for software, as a just average robot, and turned into my biggest project yet, with goal of making cheapest and the best beginner robot arm. I mean, for sure, it's best in its price because there's no other robot that I can compare it with, but is it really good? That's what you can judge. So now I want to tell you how I managed to do this, my plans for it, and everything I learned making this thing. I think that's the part everyone watching this video are most interested in, to also learn new things, but you need to watch up to the end for this. And now for the robot stuff. Starting this project first I had to choose the components that are cheap and easy to use. So for the computer I chose Arduino Mega plus optional Raspberry Pi 5. Then quickly realized it was completely wrong way and changed them with Arduino Uno Q. Yeah, I know this still isn't really cheap, but computer is very important. It terms a lot of robot capabilities. But if you want to go as cheap as possible, any Arduino Uno fits here. Next, for the motors I choose NEMA 17, HDD5M belts for the transmission, because those one are too expensive, and TMC 2209 as the drivers. Then I designed its first very original version, with arms somehow longer than I originally planned, and things like emergency stop buttons and end of every joint, or too complicated connection with every Arduino pin. And talking about its design, why is it so different? Most robotic arms have that human arm-based design, so why this one don't? Well, cheapest home robot also means entry point. So it needs to be as intuitive as possible, and this construction is just it, because instead of using complicated formulas to know how to rotate the tool in the right direction, you use axis 1, 2 and 3 to get it into position, and then same angles on 4 and 5 to counter the rotation. It's a lot easier to use, but have significantly less freedom of movement than regular arm, so after finishing it I also want to make more regular version. But now coming to this one. After printing it, I ran into first major problem. Connecting stepper drivers. You cannot do it on breadboards without getting constantly disconnecting spaghetti. It was really a problem because I couldn't find any board capable of this, and I had to design my own one. So I made my first in life keycard project and sent it to this Chinese company. It was surprisingly easy until I realized how many mistakes I made here, like putting modules directly on power lines that cause power spikes, connecting whole logic and power ground into one line, or setting 16 microsteps. This one is very important, but I come back to this later. But even with that problems, it still worked. I mean, for the most, sometimes to think of some of the drivers, but it worked. So I left making new one for later and assembled this robot for the first time. And it didn't move, like completely, not even by a hand. That was important lesson to do not trust everything that ChatGPT says, because I was lazy and just copied every diameter for the transmission he gave me. Luckily this was just a small error, so I adjust gears and lengths, this time using cloud and actual testing method, to shorted second segment, so now arm length match original plan and motor strength. Motors also got upgraded with stronger ones for better stability. So after all of that it worked terrible. Like yes, it moved, but very unstable with giant backlash. As you can guess, HDD5M belts were a big mistake from the beginning. So after that little fail, I switched every belt to HDD3M that I previously used in my robotic actuator and checked to work really well. This time testing every parameter from the beginning. And I also designed a lot of ARM parts, this time focusing more on stability, access to components, and simplifying construction. So now rebuilt with right belts, robot finally moved how it should, but it still had two huge problems. First one with electronics, so I come back to driver board design and change it completely into smaller but much better version. Now with TMC2208 drivers set to 1 microstep, because how comes out? More microsteps means less noise and more precision, but also less rotation moment. But yes, with new board it worked a lot better, now really close to what I wanted to achieve. And the second one I thought from the beginning. Because even if main point of that robot is its price, I also wanted to make it better at some point. And that point is no need of calibration after every reset. By using something that measures the axis angle from the exact same point at every time. Like potentiometer. But who worked with potentiometers knows that their precision doesn't really exist. I needed something a lot more precise, like magnetic encoders. Those are the only ones in budget of that project, and even if they technically have something like base absolute angle without calibration, how exactly do you want point that round magnet they are using for some physical reasons to face the right direction? It means first telling where is front of the circle, and then attaching this circle with precision under 1/10 of the degree. It's kinda impossible. That's why I made the device that does this outside and calibrates magnet on a 3D printed arrow that I can then connect with encoder in one case making my own absolute encoder, the AA270. And now for the last huge update. You see that base? It looks great, clean, modern, and is absolutely terrible. Complete lack of stability is only beginning. It is huge circle for the square components, what means a lot of wasted space and material. It's also completely closed, so to access any components you need to dismantle everything and then assemble again, what also is a real nightmare. So considering that and some smaller issues, I decided that better and easier is to design completely new base than trying to do anything with that one. Now it looks a little bit irregular, but it's a lot more stable, really easy to assemble and allows you to access whole electronics after removing only 4 screws, even while working. Plus uses more regular bearings, less material and less cables, so it's even cheaper. And that's where we are now. It's still a prototype with a lot to upgrade, but it's already available for you to download for free here on Kults. Waiting for the suggestions or your own upgrades to help expand this project. And as we're getting closer to the end of that video, some of you may say that there is still something missing. Here is the hardware, but how to code this? Other robots use some sort of coding app, and I didn't tell you about anything like this. Well, that's because I didn't prepare one. And just hardware base is fine, I think, but much better will be robot easy to use for everyone from the start. So my next step gonna be making my own dedicated app for this and other robots I plan to make. So subscribe to do not miss it, of course.